Hello, this is Miss Moore, and today during chemistry we're going to discuss significant figures. The essential question is, how is a significant figure determined? By the end of this lecture, you should be able to fully answer this question with confidence. Okay, here we go. What is the point of significant figures? Significant figures, also known as significant digits, and truthfully, most people refer to them simply as sig figs. So sig figs are a way to numerically represent not only the value or number of a measurement, but how close to the actual value or how precise the measurement is. As an example, if I weighed an object and came up with the measurement 152 grams. If this number is written in significant figures, it conveys two very important pieces of information. First, the number represents the mass of the object, 152 grams. Second, this number represents the level of confidence I have in the accuracy of my measurement. Now, at this point, I'm pretty sure you're completely confused. Please do not worry about that. I'm going to go through a series of examples that are going to help clear things up. I'm going to measure the length of the cloth using two different meter sticks or rulers. These rulers are the exact same size. The difference is the number of gradations. The top ruler has less gradations or divisions than the bottom ruler. So we should be able to get a more accurate measurement. We should be more confident in the accuracy of our measurement using the bottom ruler. I'll start with the ruler with less gradations. I'll first note that the cloth lies between the 60 and the 70 centimeter mark. So I know that the length of the cloth is going to be 60 something centimeters. Okay. I know it's going to be 60. Okay. However, for the something, I'm going to have to guess, or a better way to say it is estimate. I'm going to have to estimate that number to the best of my ability. So let's see, I'm going to say it is 62 centimeters. So using this ruler, I came up with a length of 62 centimeters. Now, do I feel really confident about this measurement? I feel good about the 60. I know the length of the cloth is 60-something centimeters. I think, or I'm estimating, it's 62 centimeters. Let's measure the cloth again, this time using the ruler with more divisions. Again, I know the cloth lies between the 60 and 70 centimeter mark. So I know it's 60 something. This time, however, I know that it's 62 centimeters. So measuring the cloth with this second ruler, I came up with 62 centimeters. How confident do I feel about this measurement? Well, this time I know the 60 and I know the 2. I know it's 62 centimeters. So I likely feel much more confident about this measurement than I did about the first one, where I knew it was 60 and I estimated the 2. So I think it's 62 centimeters. And this brings us to the point of significant figures. What if you didn't see me measure the cloth, but only saw the number 62 centimeters written down? How would you know which ruler was used? How confident would you be in that number 62? Does that 62 represent 60, I think, 2 centimeters? Or does that number represent 62 centimeters? That is the whole point of significant figures. Using significant figures allows a number to represent two important pieces of information. First, it allows for the numerical representation of the measurement, and second, the degree of confidence in that measurement. So when using significant figures, the significant figures in a measurement include all of the known digits. For example, in our first measurement, the 6, we knew the 6, plus one estimated digit. Again, in our first measurement, we estimated the 2. So using significant digits, you can know how exact a measurement is just by looking at the number written down. If you're still confused, please don't worry about it. We've got more examples to come. Okay, let's take a few more measurements, this time paying particular attention to the digits we write and thinking about applying significant figures to the measurements. All right, we'll measure the length of this box here, and we'll start with the top ruler. Okay, the box lies between the 70 and the 80 mark, so we know it's going to be 70-something centimeters. We know the 70. The something we're going to have to estimate, and I'm going to estimate it's 74. Okay. So using the top ruler, I came up with a measurement of 70-something centimeters, 70 probably 4 centimeters. Now let's go back and see if we appropriately applied significant figures. Okay, so when using significant figures in a measurement, you need to include all of the known digits. Did we do that? Yeah, our known digit was the 7, plus one estimated digit. Did we do that? Yes, we estimated the 4. So for this top measurement here, we appropriately applied significant figures. Let's also take note of how many significant figures this particular number has. Basically, the number of significant figures is how many digits you wrote. We wrote 2 digits. So this number has 2 sig figs, or significant figures. Now let's measure the box again using the lower ruler. Okay, and again, the box lies between the 70 and the 80 centimeter mark. So we know it's going to be 70-something centimeters. We know the 70. And this time we also know the 4. So using the bottom ruler, we came up with 74 centimeters. So let's go back and review. Did we correctly apply the correct number of significant figures? When using significant figures in a measurement, include all of the known digits. We knew the 7, we knew the 4, we did that. Plus one estimated digit. That we didn't do. So we're going to have to go back and find an estimated digit. So what are we going to estimate? We already know there's a 7 and we know there's a 4. Well, the next level of accuracy would be the decimal point. If the box is exactly aligned on the 4 hash mark, it would be 74.0. If it was slightly to the right of the 4 hash mark, it might be 74.1 or 2 or whatever. We can't really tell from this view. So that would be our estimate. I'm going to say it's directly aligned. I'm going to say that the measurement for the box is 74.0 centimeters. How many sig figs now does the lower number have? I come up with 3 sig figs. So now, even though we basically got the same number, the same measurement for both rulers, 74 and 74, the bottom one shows that we're more confident about the number because there are 3 sig figs there. All right, hopefully this is becoming a little bit clearer. We will try a few more examples. Okay, let's try a few more measurements here. This time, however, why don't you try to do it on your own? Figure out what you know, what you're estimating, and how many sig figs there are. So hit pause, go ahead and do that. When you're done, hit play. We'll go through it together. All right, this time the line lies between the 40 and the 50 centimeter mark. So we know it's going to be 40-something centimeters. We know the 40, and we have to estimate the something. I'm going to estimate that it's 43 centimeters. Now you may have estimated 42 or 44 or whatever. That's the whole point of an estimate. We all agree that it's 40-something. The estimate comes in, I say 43. What did you say? All right, so how many significant figures does this number have? 2 sig figs, or 2 significant figures. All right, one more. Again, why don't you hit pause and try this on your own, then hit play and see how you did. This time, again, the line lies between the 40 and the 50 centimeter mark, so we know it's going to be 40. This time we also know it's going to be 3. And from there we can make an estimate, and I'm going to say 43.5 centimeters. Again, you may have estimated something other than 0.5. That's the reason it's an estimate. All right, what's our sig figs? 3 sig figs. All right. Okay, at this point, if you're feeling fairly comfortable with writing significant figures from measurements, go ahead and continue with the lecture. If, however, you're not feeling very comfortable yet, I suggest you rewind the video and watch it again and write down any questions that you have, anything that confuses you, so we can discuss it. Last topic for today, significant figure rules. We were just discussing how to write a number using appropriate significant figures from a measurement. We are now going to talk about how to determine how many significant digits there are in a written number. We'll start by talking about non-zero digits. So when are non-zero digits significant? A non-zero digit is a digit that is not a 0. So a 1, a 2, a 3, a 4, a 5, a 6, a 7, an 8, or a 9. Okay, and luckily this rule is super, super easy. Every non-zero digit is significant. Let's try a few examples. If I were to write the number 2, 1, 1, 6, 2, 8, all of these digits are non-zero digits. So they're all significant. So how many significant digits are there in this number? I come up with 6 sig figs, or 6 significant figures. All right, how about another one? 8.296. This time, there's a decimal here. But the rule doesn't talk about decimals. We don't need to worry about whether or not there's a decimal there. We're just looking at the digits. So all of the digits are non-zero, which means they're all significant. We have 4 sig figs. So when we're talking about non-zero digits, it's pretty easy to determine the number of significant digits. They're all significant. Let's next discuss when zeros are significant. Unfortunately, the when zeros are significant is a little bit more complicated than when non-zero digits are significant. Basically, sometimes zeros are significant, sometimes they're not. What I'm going to do is give you the 2 rules indicating when zeros are significant. If the zeros do not follow one of those 2 rules, then they're not significant. All right, so first of all, zeros between non-zero digits are significant. So if I had something like 2002, let's figure out how many of these digits are significant. The 2 and the 2 are significant because they are non-zero digits. What about these 2 zeros? Are they significant? Do they fall between non-zero digits? They do, which makes them significant. So all the digits in this number are significant. This number has 4 sig figs. Okay. Next, let's try 36.0005. All right, you'll note this time there's a decimal. And at this moment, the decimal doesn't matter. We're talking just about the digits. So we'll ignore the decimal. Again, the 3, the 6, and the 5 are all significant because they are non-zero digits. What about these zeros? Are they between non-zero digits? They are. So that means that all of the digits in this number are significant. So this particular number has 6 sig figs. Okay. Hopefully you feel okay about this. We'll move on to the second rule. Zeros before and after a decimal are significant as long as there is a non-zero digit before the 0. Okay, so this time we do need to think about the decimal. One more time, zeros before and after a decimal are significant as long as there is a non-zero digit before the 0. Okay, let's try several examples. We'll start with 600.0. Let's figure out which of these digits are significant. That's 6. Significant because it's a non-zero digit. All right, how about this first 0 here? Is it between two non-zero digits? No. But is it before or after a decimal? Yes. And is there a non-zero digit before the 0? Yes. That 0 is significant, as is this one. How about the third one here? It's after a decimal, and there is a non-zero digit somewhere before the 0, so it is also significant. So in total, this number has 4 sig figs. Okay, let's try 67.020. Okay, the 6, the 7, and the 2 are all significant because they're non-zero digits. How about this first 0 here? It's between two non-zero digits, so it's also significant. And this last 0 here, it's after a decimal, and there's a non-zero digit before the 0, so it is also significant. So this particular problem has, 5 sig figs. All right, how about 200? The 2 is significant because it's a non-zero digit. What about these 2 zeros here? Are they between two non-zero digits? No. Are they before a decimal? All right, let's stop and think about this. I do realize that normally, if there's no decimal written, there's a decimal implied at the end of the number. And while that's true, when we're talking about significant figures, the only decimals that matter are the ones that are written down. And being that there's no decimal written down, these zeros are not in front of a decimal. They're also not between two non-zero digits, which means they are not significant. This number only has 1 sig fig. Okay, one more. How about 0.0050? Okay, the 5 is significant because it's a non-zero digit. What about this 0? It's not between two non-zero digits. It is before a decimal, but there is no non-zero digit before the 0, so it's not significant. How about these 2? They also are not between non-zero digits. They are after a decimal, but there is again no non-zero digit before the 0, so they are not significant. What about that last one? It's not between two non-zero digits. It is after a decimal, and there is a non-zero digit before the 0. So this last 0 is significant. So this number has a total of 2 sig figs. Okay, that's it for the rules on determining sig figs. If you don't feel comfortable about this, review, jot down any questions that you have, and all we have left to do now are to try a few practice problems. All right, sig fig practice. What I'd like you to do is on your own determine the number of sig figs for 1 through 5. So hit pause, try to figure it out, then hit play, and I'll go through it with you. All right, so for number 1, I calculate that there are 5 sig figs. The 8, the 4, and the 5 are all significant because they are non-zero digits. These 2 zeros are significant because they're between non-zero digits. Okay. For number 2, the 8, the 9, and the 0 are all significant, which gives us 3 sig figs. The 8 and 9 are significant because they are non-zero digits. The 0 is significant because it comes after a decimal, and there is a non-zero digit in front of it. Okay. Number 3, the 2 is significant and the 3 is significant. These 2 zeros here are not significant because they are not between 2 non-zero digits. They are not before or after a decimal. Okay? So this particular number only has 2 sig figs. Okay, number 4. The 4 and 4 are significant because they are non-zero digits. The first 3 zeros, none of them are significant because they are not between non-zero digits. They are before or after a decimal, however, there's no non-zero digit in front of it. This last 0 is significant because it's behind a decimal and there is a non-zero digit in front of it. So this particular number has 3 sig figs. Right? And the last one is number 5. 4, 9, 7, 6 are all significant because they are non-zero digits. These 2 zeros are also significant because they're between non-zero digits. So we have a total of 6 sig figs. All right, that's the end of the lecture. As I keep saying, please review anything you're not feeling comfortable with. Write down your questions so we can talk about it.